In this video, we're going to talk about how to convert the rectangular point -4, -4 to a polar version, which is going to have an r and a theta. So remember, when we have a point that's given to us in terms of rectangular coordinates, we have an x and a y value. And what we're trying to convert to is we're trying to convert in polar to something that has an r value and a theta. And so we need to figure out what r is as a number, and we need to figure out what theta is as a number, and then we'll be done. Now you can see written in blue, we have x is equal to r cosine theta, y is equal to r sine theta, and x squared plus y squared is equal to r squared, and theta is equal to the tangent inverse of y over x. And those are the things that we're going to use to convert from rectangular to polar and vice versa. And specifically for this video, since we're going from rectangular to polar, we're going to use the items on the second line right here. Because if we solved x squared plus y squared equals r squared for r, in other words taking the square root of both sides, that gives us the first number we need, which is our r value right here. And then the second number we need, we'll just plug it into tangent inverse of our y value divided by our x value, and that will give us theta. So that's what we're going to do here. So I'm going to go ahead and rewrite the x squared plus y squared equals r squared in terms of just solving it for r. Like I said, that's just going to be the square root of both sides. So the square root of x squared plus y squared is going to give us r, half of what we need. And we know our x value is -4 and our y value is -4, and so we can go ahead and plug those into the place of x and y. So we'll have the square root of -4 squared plus -4 squared. Be sure you put a parentheses around those -4s because you want to be sure that negative is part of the thing that's being squared, and that's going to give us r. And so in this case, we have 16 plus 16 under the radical, giving us r. So we're going to have the square root of 32 is equal to r. Now we can simplify that into 2 times the square root of 2 times the square root of 16, which would give us 4 times the square root of 2. Because like I said, this is 2 times 16, all under the radical, and then the radical, or the square root of 16, gives us the 4, and then of course the square root of 2 is left over. And so our r value is going to be 4 times the square root of 2. And so that's the first of the 2 things we need. Now for the second of the 2 things we need, when we're solving for theta, it's always really smart to go ahead and plot the point -4, -4 in the beginning so you can know which quadrant you're in, and so you can know what angle you're going to get. And the reason for that is we're using tangent inverse, and tangent inverse is only defined for quadrants 1 and 4. And so therefore, if we're trying to solve for something in this case that's in quadrant 3, we need to be able to find something that's equivalent to it because our answer is going to be given to us in quadrant 1. So let me go ahead and show you how this works, and it'll make more sense probably as we go about the problem. If you plot the point -4, -4, and I'm just going to do it on the unit circle, or using kind of the unit circle, if we have our x axis, of course, and our y axis, we would just go to the left 4 and down 4. So we would end up somewhere down here in the third quadrant. Now I know really we would be 4 units to the left and 4 units down, and this is of course less than 1 unit because we're inside the unit circle, but I'm just using it kind of as an illustration to show you which quadrant we're going to be in. And so we know we're looking for a quadrant 3 angle. And to keeping that in mind, we can go ahead and plug our y and our x into our theta equation. And so we know theta is going to be equal to the tangent inverse of y over x, which is -4 over -4. And you can simplify that if you want to, or you can just go straight to the calculator with it. And so what you want to do is you just want to type in directly tangent inverse of -4 of -4, same thing as tangent inverse of 1. And what you get if you're in degree mode is you get 45 degrees. Now I'm going to put a question mark beside that because we need to ask ourselves, is 45 degrees, which that's the same thing as pi over 4 right here, is that in quadrant 3? And the answer is no. And so therefore that's definitely not going to be the answer, because like I said, tangent inverse is only going to give us an answer in quadrant 1 or quadrant 4. But the way you can work this out is you can just follow this blue line that we have for 45 degrees, just follow it straight through to the other side, and that will always give you your answer. And in this case, it's 5 pi over 4. Let me erase some of that. Got a little messy. In this case, it's 5 pi over 4, or 225 degrees. And so you can see that's the 45-degree triangle that would be in the third quadrant that relates to the 45-degree triangle that is in the first quadrant. And so the values are going to end up being the same. And so it's not 45. You have to use a little bit of critical thinking knowing which quadrant it's in. It's definitely 225 degrees, or if you want to go with radians, it's 5 pi over 4 radians. So that's why it's pretty handy to have a unit circle around you whenever you're doing these problems, because if you do get one of those cases where the inverse, sine, cosine, or tangent function gives you something in the wrong quadrant, you can just kind of draw through to the other side, straight through the origin, and get your answer pretty quickly. And so our solution here is, instead of -4, -4, x and y, we have r being 4 times the square root of 2, comma theta, and I'll just go with the radian measure 5 pi over 4. And that's r and theta. So that's the polar version of our rectangular point -4, -4.